run this. All right. So you can go back and watch this. All right. So all right. So here's Valerie's Gourmet. Okay. And again, you have 6 things. And by the way, this is out under week 13. Okay. This will show you how to solve Valerie Gourmet gift database design problem. Okay. We got to identify data elements. And then we got to subdivide each element into its smallest useful component. Identify the tables, assign keys, identify primary keys and foreign keys, review the data structure, in other words, normalize your database, and identify indexes. Okay. And again, we don't know whether this was a cute computerized system or not, doesn't matter. We are basically going to design a database for our new system. Okay, and we're going to take a look at Valerie Gourmet gifts, specifically at the order processing system. Okay, so right off the bat, we try to find make a data flow diagram. Okay, why do we make a data flow diagram? We're just trying to understand what the process is. A customer calls in. We probably start here. Customer calls in, makes an order. The order is processed. Circles, or in this case, whatever these are called, are processes. This is an entity. A customer is an entity. So the order is processed, creates an order. We put that in our data store or our database, okay? And in this case, this is going to become 1 or 2 tables. And I know it's already going to become 2 tables because I've gone over it. And then we have to order from a catalog. This is really where our inventory is. It tells us what the quantity on hand is. And then it's going to update the quantity on hand, okay? So we know that catalog most likely will be its own table, okay? And then as orders processed, then we prepare another document, a packing slip, and we ship the order on out. Okay, a very simple data flow diagram showing things coming in and going out. In some cases, we're going both ways, but in other cases, we're only going one way. Okay. Any questions about this data flow diagram? Does it help you understand what's going on?
Yeah, it helps.
All right. So, and then we're presented with 2 more documents from the user. Okay. So this is how they fill out an order form for a customer. Okay. And then probably send some type of packing slip back with this information. Okay. And so, you know, they as a customer calls, they'll take their information, obviously. And then they'll record it. Then they'll take the order part of that. Some of the things to notice is method of payment, probably some type of checkbox. So we're going to have multiple options here. Card number, you have to determine whether a card number is valid. What if they send a check? Can the card number hold the check number, for example? And you may have a separate column for check number if they do send a check. So these are things that we have to have in our database. These are some of the other things that go along with the order. You know, where we get price from, where we get quantity from, then we get total price, and then we get our merchandise total. Then we got to add sales tax insurance, which is down here, which by the way will probably be another table, and then UPS, and it looks like this company has two ways of shipping things. There's a slow way, and then there's this way, which costs a little bit more. So this is going to probably be some type of checkbox for that. Okay. And then we have how much money they're actually spending. And by the way, whenever you see electronic signature, that's going to be part of your database, even though currently they might sign something or whatever below, or we might sign something. This signature has to be represented in the database. All right. So it's a lot of information that we gather. We're not really worried about this information. This would probably be in another system, or like a table that contains our name and our information, but we're not going to design this one. Okay. Don't forget your daytime phone number. All right. All right. So, and then we get this sheet. This is actually our catalog. This is by itself is going to be a table. Okay. So we just need to process this information. Okay. This is really an inventory table. So we're calling it catalog here, but a lot of times this would be called inventory. Just an FYI, so that you know when you look at a database. All right. So their inventory is very, it's a little bit eclectic. So, you could probably put, once I started doing this, I would probably have a category, a catalog category. Sounds a little redundant, but that's probably what I would do in the long run, but we're really not concerned with that right now. So we start designing the database. We identify the data elements, and really it's just a matter of, plucking things out real quick. You see customer name, customer address, customer phone, order date. Again, I anticipated the need to have order date, even though they don't have it on their sheet. Catalog number, how many, catalog description, catalog price, total price, merchandise total price, method of payment, credit card number. Again, we could have potentially a check number here, but we'll just leave it like that for now. Signature, sales tax, shipping and insurance, UPS second day upgrade, total US funds, total order for shipping costs and quantity on hand. So I quickly ran through the forms that I had, and I gave them column names, or data element names, we'll call them at this point. Okay, and then we got to further break it down. So what we're going to do is take things like customer name, we're going to put it into first name and last name, address 1, address 2, city, state, zip. Even though some of those fields are already represented on the form, we want to keep all of our customer address stuff together. Okay. Any questions? All right. And then you start to put things in the tables, okay? And notice how I go about this. For example, catalog number. I would never use a pound sign in my database, okay? So I have a way I name stuff. I call it, anytime I see number, I call it NO, okay? NO is the abbreviation for number. So that's what I do. Okay. How many? Okay. Better way of saying that is quantity ordered. Okay. So how much did they order of that item? Okay. And notice how I'm using what a modified camel way of naming my variables. And what does that mean? That basically means that every new word has a hump, or it's capitalized in my my column name. Okay, that's just a method I've used for years. So, this is what I'm doing. And then I put price, but notice that I'm saying that where is price coming from? Okay, so it's coming from the catalog table. Okay, but it might still be important to have price in my orders table. Anybody know why? Because what if price changes in my catalog table? I want to know what, at the time when they place this order, what their price was. And if we got to go up because of inflation, at least I'll have the record of what this customer paid last time. Okay. Now, merchandise total price, again, and total price, these things are calculated, and because of normalization, we would never have these in our table because we can calculate total price by quantity order times price, and we calculate the total order price, and that would be adding all these together, adding all the total prices together. Okay. I think I said that the opposite way, but the idea is again, you don't put fields that you can calculate into your database. And there are exceptions to that, especially when you get to data warehousing, but we're not going over data warehousing. This is to normalize our data. And then I do payment method and credit card number and signature, which will be some type of checkbox based off of what we have the customer do online, what we have our people do online. So this would check a box that it was signed. Sales tax. And again, even though I'm not going to put a states table in here, sales tax is dependent upon the state. So you would probably have some type of states table already in your system, and you would just have to make sure that that state sales tax was kept there and kept up to date there. Shipping, yeah, we're going to make a shipping table for shipping and insurance. Okay, shipping upgrade, yeah, so we would do that. And again, total US funds and total order for shipping costs. We would calculate those fields. Any questions? Now you're going to need to know this for our project number 1, okay? How to do this. The second table I've identified is the customers table, no doubt there. The address, all that stuff. Customer state, again, that would be we would verify that against the states table. We don't want people randomly misspelling states. So they would probably type in a code like MI, and it would make sure that that is an appropriate state in our application. First name, last name, again, split out. And notice how I'm using cust here to represent customers. You don't have to do that because first name and last name will always be preceded by customers if we need to use it. Okay. This might be a fast way of doing stuff. So there's no problem doing it, putting cust in front of it either. Okay. It just means more typing in the long run. Catalog, very simple, catalog number, catalog description. Notice how I abbreviate number and description. Again, these are standards that I've been using throughout the years. So I always know DESC is description. I always know NO is number. Okay, I know it can spell no, but, and I could have did the same thing with quantity on hand. I could have did QTY. These are regularly accepted abbreviations for quantity. Okay. So I start designing, I'm really in the process of designing my tables. Now I identify my primary keys, okay? So in each case, indeed, definitely the first two cases, I created my own primary key. So I added a unique identifier, and you need to know how to do that in your table when you create a table, okay? And maybe we'll go over a little bit of that. So let's just, quickly go over this. I'm going to make my little database, we'll call it Valerie's. Okay, so let's go ahead and create a database here. New database. Now let me go right here and do new database. And I'm going to type in Valerie. Okay, now notice how there's going to be logical names placed on the database server, which in your case is your computer. And it does initial size and log size. A little bit about this. This is where all your data is going to sit in Valerie. Okay, it'll be valerie.mdb, I believe. And you can see where it's going to create it, right? And your log, by the way, what's a log? And it's called a transaction log. And basically it's a method that databases use to allow people to quickly insert, update, and delete data. Okay. It keeps the transaction. So you do stuff to your database, it may or may not do it, but it keeps in the transaction log, and it runs a transaction log when it can do it, and it will do the things that you've told it to do. So every database has a transaction log. Okay. Don't need to know it right now. I'm just telling you. In the initial size, it is important, especially when you're dealing with big databases. You know, you don't want your database growing by 64 megabytes every time you do an insert. Okay. And I can guarantee that some of the things you're going to be inserting are going to be much larger than 64 meg. So that would really slow the system down. So you want to anticipate your initial size of your database and put like 1/3 or 1/4 here for your log. Okay. So if my database is going to be 1 trillion bytes or 1 terabyte, then this would probably be about 250 billion bytes. Okay. You don't have to worry about that. Don't, you know, I just want to show you that. But let's go ahead and create that. So we've created our database. You're going to create your own database for bowling alley. Okay. And so now as we expand that, we should see Valerie.
Professor, were those two rows the primary and foreign key, as we just saw?
We haven't done that yet, but we're going to. Yeah. So let's I'm going to create those 3 tables just to show you. I'm not going to put all the columns in, but just to show you how to do that. So we're going to go right here. Okay. And let's go ahead and let's create the customers database. Okay. So we're going right click on tables, click new, click table. And this is how you create a table. Okay. And remember, I said we're going to add our own identifier here. I guess I should follow customer, right? You know, and again, this is, and you all have seen this, but this is something that I always do. I mean, I create my own primary key for the most part for tables, and I know it has to be an int, and I know I need to go down here and tell it it's going to be an identity field. And so I say, yes, it is an identity field. There's a little drop down, yes or no. And then the increment says, the seed says start at 1. So the first customer ID will be 1, and then add 1 every time you go to add a new row in your customers table. Okay. And then we might put customer last name. And varchar 50 should be fine. And customer first name. Okay, and all the other fields should be added too, of course. Okay, now the last thing I need to do with this table is I need to make it a primary key. So I mean, the column I created, the customer ID, I'm going to now make it the primary key. Okay. And then as I come out, we're going to rename the table to customers. Again, always remember, like I put an S after that, because it's not just one customer, it's a bunch of customers. Okay. So it goes ahead and it creates it. If we refresh our tables, we'll see it there. And by the way, at this point, I can now, if I wanted to, I could start adding stuff. Okay, so it'll bring up a little form for me. Again, I can't type anything in for customer ID because the system's going to add it. But let's just say I add me and my brothers. Okay. And my last but not least brother, who drives me crazy. Okay. So now I've added 3 rows to this table. Okay. In your exercise, you're going to be asked to add rows. And that's how you do it. Okay, so those rows are in there. Yes.
Which one is the foreign key?
Well, we haven't done a foreign key yet.
Oh, okay.
Okay. So our foreign keys is going to come when we get to the orders table, but let's quickly just create one more table. Okay. Let's right click and just create the catalog table. And again, I could do this, but in this case, we're going to assume that catalog number is unique. So we're going to just use catalog number. And we're not exactly sure if it's indexed integer all the time or not, but I want to show you something. If we go back and we look at our form, notice this. It always seems to be 4 characters. You would have to make sure of that. But notice how it has some of your characters have a 0 before it. So what's that tell me? It tells me that I might want to use alphanumeric, which is varchar or character. Okay, let's assume that it's always 4 characters. All right. So we're making an assumption here, and we go back down. Okay. So this is, you can see what I'm doing down here. So I'm going to put these 4 fields in. All right. So let's go ahead and do that. We'll just call this character Now that you might not want to allow nulls here, okay? And then we're going to catalog description. And you might be a varchar. Let's say that will go with 50 for right now. Quantity on hand. And quantity on hand, we know, is always going to be an integer. Okay, so we'll roll with that. And then finally, price. And we'll just call this a money data type. Now, we can set defaults for this, okay? For example, we could say that the default for quantity on hand is 0. And we could do the same thing for money. Now we could make this any integer, well, in this case, any number we'd like to, okay? But 0 makes sense. The other thing is we are going to try to make this our primary key. So let's set it as primary. All right, and now let's save our table. In this case, we're going to call it catalog. Why aren't we going to call it catalogs here? Did I say everything will have multiple rows in it? The reason we don't call it catalogs is because a catalog, by definition, has multiple items in it, right? So that's why we call it just catalog in this case. Again, designing a database is really about what makes sense. And again, if we want to refresh, we'll see it, and we can enter data into it by going to edit. Okay, so let's say 0402 is 1. I don't know. To say paper plates. I don't think that would be part of Valerie's gourmet stuff. You know, we go with those. We don't know what the price is. Well, let's say we don't know what the price is here, so we don't put that in. Default to 0s always around. Let's say we add another item, and we'll call it dishes. How's that for being unique? And we'll say we have 20 of those on hand, and the price for each dish is what, $10? Okay. And that, so we've added 2 items to the catalog. And by the way, if we wanted to see that, we could select them, and we see that there's our 2 items. Any questions? So right now we've added 2 tables, and the thing is we're not going to add our 3rd table yet. Okay, and I'm going to show you why. The problem with our third table is this. It's not normalized. So, and we've identified the primary keys for customers and for catalog, but I will tell you this, we haven't done that yet for orders. And so we don't really know what our foreign keys are going to be yet. We can take a guess, but I would prefer to wait till we design the orders table. So we're going to come back to that. So to get something in first normal form is to not have multiple things in our catalog. For example, when somebody places an order, we don't want to have woke topper and comma crispy can. Okay, we want to have we have to split that out, and the way you do that is by doing something like this. And this brings our table into the first normal form. Okay, where every order, everything that we've ordered has its own row or line. Okay, but this isn't good enough. Now we want to bring in the second normal form. So every non-key column must be dependent upon the entire primary key. Okay, so we start off with order ID, customer ID, which is going to be a phone number, and then catalog number. At this point, we're saying that our key would have to be order ID and catalog number. Okay. So this would be what identifies each row, order ID and catalog number. Okay. Not necessarily customer ID, even though we could use that. So what we have to do though is to bring it down into a much better normalized way, our data would start to look like this. We would add up a child table, okay? And in this child table, the catalog description is dependent upon the catalog number, okay? So we've taken the second normal form because these two columns are dependent upon really these two columns, and really in some cases it'd be just this column. But we still have one more problem. Anybody know that? The problem is that to bring it to the third normal form, every non-key column must be dependent only upon the entire primary key. And in this case, it's not. Your catalog description is dependent upon catalog number. So what's that tell us? Well, it tells us that to get to the third normal form, we would need a catalogs table, okay? And we've already made our catalogs table just like that one form. So we have to take out catalog description and put it in the catalogs table. And now all the user has to do is put in catalog number, and it will pull back the description, okay, from the catalogs table. So this is bringing it to the third normal form. In your project, I'm going to ask that you normalize to the third normal form, okay? So you're going to have to identify when does it make sense to make another table, okay? So we had to make two additional tables at this point. We had to split the order table up into two tables, a parent and a child table, and then we also had to create a catalogs table, okay? So that's how you normalize your data. And we end up with something like this. Now, and I'll show you, we're going to add the orders table and the order details table, okay? And we'll be real specific here. So let's just go ahead and do those two tables, okay? So let's go up here. We're first going to make our orders table. And again, I'm adding a column because I don't see any unique column for it. Okay, and I'm going to call it int. And I am going to make it an identity column. Okay. So we'll go down here, identity, expand this, select the drop down, say yes. All right, we're good. And then we're going to, we know that every order has a customer and we already have a customer's table. So we're actually entering the foreign key here. So we're good there. Okay. And then we'll just put in one more column that's not a part of the key. And we'll call it date. All right. And we're going to call this the orders. Well, we forgot to put our primary key in. Let's make this our primary key here. I always forget to do that and have to go back. All right, so let's say yes there, and we're going to call this orders because it's going to be multiple orders. All right. So we now have that table. We're not going to enter any data in there. And now we have one last table. We have to make the orders table as the parent. We have to make the order, in this case, we'll call it detail table. And normally what you would have in here is you would have order ID, okay? But I'm going to do something that is really the database designer's choice. I'm going to start off with, I'm going to create another unique key. Okay, and what we're going to make that identifier. And I hope I can explain this to you well, why we do this. So this is going to become our identifier. And we know we need order ID. And that's going to be, it's actually going to become our foreign key. And then we're going to have catalog number. And we remember that it's character 4. But this is going to be a foreign key. And we'll say price. And it's going to be money and quantity. And this is really quantity ordered. We can specify that if you like, and we're going to make this an int, not any, an int. All right, and again, we're going to make this our primary key. Now, important thing to understand, you could have made order ID as part of your primary key. The reason we don't need to is because we're going to allow SQL to add its own unique ID here, okay? This will become the foreign key for it, but we're going to allow it, we're just going to use this as our unique identifier. Perfectly valid to make order ID part of your primary key though, because logically it makes more sense. I just know that this is the preferred way that we do these things now. Any questions? So let's save this. We're going to call this order details. Okay. You know, you could have called it order items, or you could, you know, there's a lot of different ways you could have named that. But now
Professor?
yes.
Can you explain more about the parent-child relationship between two tables?
Yeah. So let's go ahead and create a database diagram. And this should help explain that. And what we're going to do with our database diagram is we're actually going to assign foreign keys. Okay. And I'll explain it as we go through it. Yeah, whatever. So we're going to use all four tables. So we're going to add them in. And I'm going to put these tables in a way that best explain everything. Okay. And again, you can feel free to move these around. I like putting customers over here. I like putting orders over here and order detail down here because this is a parent-child relationship, and catalog can go right here. Okay. Now, to create a foreign key relationship, what we're going to do is we're going to take this column and put it over here. Well, we try to, and put it right there. And so you can see that customers is my primary key table, and customer ID is the column. Same column name for the foreign key to orders. And I'll say, okay. So it's created a one-to-many relationship. And I could do the same thing here. Let me take this column and drag it right over here. Let me try to. All right. Again, we're creating a foreign key relationship. So catalog is going to be our primary key table. And order details will be the foreign key table. And so say, okay, okay. And again, because we know that order details, an order can have multiple cataloged items. Okay. So these are just your normal primary key to foreign key relationship. Now, what we've done is we've split up orders to be to make more sense, really. So we've split it up to normalize our data. We split up orders. So, and we've created order details. These fields right here, they're always the same for each order, and they go along with all the, whenever a customer calls up, it's a, and they order 5 items, these things always stay the same. So we put them in the parent table. The things that change, like different catalog numbers and things like that, prices, quantity ordered, we put in the child table. In this case, we call it order details. But notice how there is a relationship that we need to develop here between the father, the parent, and the child. Okay. And again, the way we do that is we go from the primary key table and we go right down to order ID. Okay. And we've created a one-to-many thing. So, you know, for example, your mother can have multiple children, right? Same concept here. But this is truly a parent-child relationship where these really aren't. I wouldn't define them as that. When you start splitting tables up, you create parent-child relationships. Does that help make sense?
Yeah, and then they also have to have like common keys between them. Is that correct? Like
Yeah,
the primary and foreign.
yes. And that, in this case, it's order ID. Okay. Now, what happens when we save this diagram? This is the easiest way to create your relationship between primary key and foreign keys. Just say yes, we don't care what it's called. As long as your database allows you to do this, and I'll show you in the next section how to do that, you just say yes. All right, now watch what happens. Okay, so here we only have primary keys. If we expand customers, it'll be the same thing. Only primary key. But what happens when we start expanding orders? See, a foreign key was created. And same thing with orders detail. And orders detail is actually going to have 2 foreign keys. Okay. One to its parent and one to catalog. So that's how you do all that. And so, and after you've done all this, you've entered it in, you've actually designed your database. This is the design of your database. You just have to enter all this data, all these columns in. It's not data, but it's columns, okay? And so that's Valerie Gourmet for you. Again, watch my video, watch this video to get a better understanding of that. But the whole solution is under week 13, I believe. Just make sure. So week 13, no, it's under week 12, okay? And by the way, we are in week 13. Okay. Now, we've got to go over chapters 11 and 12 so you can do your database. All right. And we've already done a lot of this, so I'm not even going to go over it. But first thing to understand is that you really have 2 different type of languages here. We've been working with the data manipulation language. That is that's the language to allow us to see data, to insert data, to modify data through the update, and to delete data. Okay, and that's called DDL, or data definition language. Now we're going to, what we've been doing this whole class is we've been doing data manipulation language. We've been doing, these are data manipulation languages. Now we're going to be doing our data definition language. Okay, and you're going to see things, you're going to see 3 different types of commands: create, alter, and drop. And for the lack of a better word, and this is truly what happens, it creates objects within your database. Okay, these are all objects. Even your foreign key definition is an object in your database. Okay, we used SQL, gives us a lot of flexibility through its GUI, but understand this, that these are actual commands that are being run in the data definition language. Okay, and I'll show you that very shortly, how that looks. All right, let's get back to that. So just remember, create, alter, drop. Okay, create creates objects in your database, and it even creates a database. Alter alters objects in your database, and even it allows you to always modify your your objects. And drop is deleting an object from the database. Very powerful commands. If you ever do a drop, make sure you're ready to do that, okay? I've ran into some problems with that where I've had to sleep overnight because I dropped things I didn't want to drop. All right, and of course, make backups. So we went to create a new database, and I explained a little bit about how this works, okay? And again, you're going to have permissions on your own computer, so it's not a problem. So don't worry about that. Just good to know that you have to have permission to do that. And by default, you will on your own computer. Formatting rules, again, what characters can and you can't use, brackets or double quotes for your column names. My recommendation is always call your tables and your columns without any special characters. And do put them together. Don't use spaces. It makes it harder. Use something like I did where you capitalize every new word. Okay. So you can run through this on your own. We're not going to spend time. This tells you how to attach an existing database. You're not going to be tested on this. Okay. So don't worry about this. You know, I told you the wrong extensions, MDF, my bad. But again, you're not going to be doing this, but this tells you that there can be a database out there, a physical database on the server. In your case, it's your computer. You can create a logical database from that, okay? And this is how you would do that. And again, creating database tables. I showed you the easy way to do it. Right click on table, type in your columns. But this is actually what's going on. It's this create table name. That's what's going on. Okay. And these are some of the attributes that you could deal with. Is identity. What's the default value? We did 2 of those. Okay. There'll be some other things that you'll be asked to add to the bowling alley. It's up to you to figure those out, okay? So, and this is how it looks, okay? And again, use the GUI. The GUI, I love using the GUI, okay? In my real work, did I actually write the code for this to create table? Yeah, I did. But that was mainly because I don't know why. I just felt more comfortable doing it that way. So I had a record, I guess. All right. All right. Remember this page. If you were in my class, you would have to remember this. You have to uncheck this, but yours should be unchecked already. Because if it's checked, when you go to do something like we did with the database diagram, and you go to save it, it will not let you create foreign keys. So you have to uncheck this. That's what that means. All right. I know I'm flying through this. Again, you can create indexes, and this is your basic way to do that. You can create, not by default, you have one clustered index, okay? And that's always going to be your primary key. So create a clustered index for vendors on vendor ID, create the clustered index, okay? So how do you do that? Let's just go ahead and do that on one of our tables. So we're going to create on catalog. So let's see. We're going to go into design and let's see if we can just click on here. Okay. We're going to create index. We're going to call it primary key unique. And in this case, it's going to be a cluster because it's a primary key. And all we got to do is say, I think it may already be added. Let's go ahead and add it. Okay. So anyways, this is now an index on our table. I have a feeling that this is our only. Let me just see something. So that's clustered, and now this is not clustered. So we've created another one, but let's delete it out. Let's actually create a non-clustered on another field. So when you create your primary key, it's going to create this one index on it, and it's going to be the one and only clustered index that you can have. So it'll do it for you automatically. Okay. But let's say we wanted to create a non-clustered index on catalog description. So we already have that one index. Let's go ahead and add it. And in this case, we're going to change it to be another column. We're going to do catalog description, say okay. And you may even want to name it like that, but you're fine. So you could rename it. You could say, okay, just say close, and you're fine. Now you got two indexes on that table. Okay, and if we go down here and we refresh, oh, I guess I didn't save it. Let's go ahead really quick and just do that again. Oh, no, that's why, because I didn't get all the way out. If we refresh, there it is. Okay, so you're going to be asked to create a non-clustered index in your project. Again, indexes speed up the lookup of by a field, and a lot of times catalog description would have an index on it. Okay, just to speed it up, and of course the primary key clustered index is automatically created. So these are speed issues that you would probably do afterwards, after you had a good sense of what you were going to need to do. Remember, indexes will slow down a database if you're doing a lot of inserts, modifies, and deletes, okay? Because not only does the database have to update the table, it has to update this index. All right, so that's creating an index for you. All right, so you can go over that and see what happens. All right, now we can also create table constraints, okay? And this will help maintain the integrity of your database. Foreign keys, we've already done it when we create our database diagram. So that enforces referential integrity between the columns. In other words, you can't put a customer ID in where there's no customer ID in the primary table. Okay. So by creating that database diagram, we just created relationships, and we created referential integrity between those columns. You can also do other things. For example, you can set a limit on the values for one or more columns. Let's go ahead and try that. Okay. So you can see here what you might do. This is the way you would code it. Let's say we want to put that into our order details table. In other words, we don't want somebody ordering something for a negative amount and we have to pay them, right? So what we could do here is let's go to our order detail part table. Let's go ahead and design it. And let's take, we'll just take, we're not going to let people put in negative quantities, okay? So so again, we can set the default to 0. Okay, but let's go down and see if there's any way we can do this. Okay, so we can't do it here. So let's go ahead and save the 0 amount. And now let's go to this properties. I might have to go actually into this column right here. Let's see. Modify. Yeah. Well, see, I might have to look at my instructions. All right, this is the way you code that. Check constraints. Okay, so okay, so the problem that I always have is I am so so we can say something like quantity ordered must be greater than or equal to 0. Okay, so it'll be that. We're quantity order. Anyways, I'm not going to waste too much time on this, but this is how you add a constraint. Let's just go back. I want to see what I did over here. I might have spelled it wrong. Okay, yeah, I probably spelled it wrong. All right, so that's a constraint. Now, if we were to add something, it would not let us add a negative value into quantity ordered. Okay. You're gonna have to trust me on that one because we're trying to fly through this. All right. And we went through how to create foreign key relationships. Again, I use the data diagram. That's your easiest way to do that. It will create that script for you. Again, we explain what referential integrity is here. Cascading deletes, cascading update rules. We're not going to do that, but basically what it means that if you delete a customer, there would be you would have to check all the orders and determine what you wanted to do in the orders. In most places, we just don't you just can't delete a customer if it still has orders with that foreign key. Okay. So that's what this means here. You know, dropping an index, dropping a table, even dropping a database. That's those statements there. This tells you how to add columns to tables. Add a new column, drop a column, you know. Needs, by the way, the word add is for adding attributes to that table, okay, to that column or to that table. All right. Again, you don't have to know the DDL. I'm going to show you how to get that. Okay. So we've done our whole database. Now, I'm going to be asking you not to give me anything on paper other than I want to see your script for creating that database with all the things I've asked you to do. This is how you do it. Okay. You can create a script for a table. And I'm going to recommend you don't do that. But if I wanted to create a script for that, let's go ahead and say yes. If I wanted to create that script, I can script the table as create. And look what SQL does for you. So you don't have to, you can use the GUI and it will take care of all the other things for you. Okay. So that's how you can script after you use the GUI to build your table or your database. Okay. But I'm going to show you something even cooler shortly. So we'll just leave that up there for right now. Okay. So you can create a script at the database level. Okay. And here's how, this is important. This is what you're going to do for me. You're going to go into your database. Okay. And you're going to right click. So you can see I have my bowling alley one already up there. I'm going to right click and we're going to go to task and we're going to do generate scripts. Okay. You're going to just walk through this. There's about 4 questions here. Just say next. We're going to script the entire database and database objects. Just do the default here. You can save this anywhere. I usually save it to a new query window. Just because I want to see what happened. And it does a review of what you've selected. And you just go ahead. And you let SQL create your scripts that you're going to email me. It really doesn't take that long. And hit finish. And what SQL's done is it's created all the stuff that's in your database. Okay, all your DDL. That's what I'm looking for. Okay, this would be my project one. Okay, and you're going to exit out of there, save it with your initials, obviously, and you'll be all set. All right, I'm just looking at the time. So we walked through all this. Okay, and you can look at that. Save the entire database and the database objects. Okay. And it goes through all that, just like you saw. And this is what it looks like. Okay. All right. Was that overwhelming?
It's a lot of information for sure.
Yeah, that's why we're not going to be tested on it, but you're going to have this as a reference to go over. This is what you're going to do for me by next week. By next Tuesday, I want you to create the database, the bowling alley project database. So the last thing I want to do today is let's take a look at our project. All right. So our project is right here, right somewhere.
Professor, I have a question really quick.
Yes.
So we're not going to be using data definition language, I think it was called. Like,
Yeah.
we're not going to use the create table code, like type it out.
Well, create table code is the data definition language, but what I'm going to recommend you use, and you could use the data definition language if you want. What I'm going to recommend is you use the GUI that comes with SQL Server Management Studio.
Mm-hmm.
This is
and then the script will be the DDL that we sent you.
Yes. So you're going to create the script by just going right clicking on your database, going to a task and going down to generate scripts. And you're going to generate the whole script of the database you've created through the GUI. Okay.
Okay.
That's it. I mean, it's so easy, right? That's what I want to see. I want to see the script. All right. But I did provide you with all the place to put all you. And again, you don't have to email me this. I don't want to see this, but I guess you could if you want to. Right here is project number 1. You're going to open up project number 1. Okay, it's good. It's a Word document. I've already opened it up. But anyways, so it's a Word document. It's called Bowling, Project 01 Bowling League. In my case, it's called 3 because I probably got it open 3 times. But I'm going to, if you walk through this, and we're going to walk through that right now, I provide you with a little data flow diagram. Okay. What we're doing is we're creating a bowling league. And a bowling league, and they're going to have a 10-week schedule. And this is how it works. Players register on a team, a bowling team, and then each team has a roster. It's going to have a team name along with all the player names on that team. So here's one of the what a card might look like. Team name is Strikers. Player name is Edith Percy. Gender female. Player address. Player phone. Player email. Player age. And is this player this bowler the captain or not? So it is assumed that the players get together before the league starts. They group each other. They group each other into different teams based on their skill level, and they come up with their own team name. The index, this is their index card, is completed by each player and given to the bowling alley owner. This league will carry 3 players for each team. Okay. The bowling alley owner then develops a 10-week schedule. Once all the registration cards are turned in. And this year this league only has 6 bowlers in it, so we have only 2 teams. So I just made it easy on you. And of course that makes scheduling easy. And thus far they've completed 2 matches, or in other words, 2 weeks. And so here's the data for the 2 weeks. Okay. So you can see all the different things that they've done. Okay. And of course, a bowler, when a game is bowled, a player can receive a score anywhere from 0 to 300. All right. Everybody hopefully knows that you can't bowl over 300 in bowling. Okay. So we're going to probably put a constraint on that so somebody doesn't put in 3,000 or 2,000. We want them to add up like this. And again, it totals out to a match score for them. Okay. The team with the highest total wins. If they're the same, they tie. So first thing I'm going to ask you to do, and again, you're not going to turn this into me, but you're going to list out all your data elements. And so I provided this Word document so you can easily do that. So we can easily type in all the different data elements. You don't have to use this, but you can use it. And then I tell you to make sure each field is broken down into its smallest component. Okay.
Professor, can you give us examples for the first 2 steps? Like what could be like a data element exactly?
No, because I did it for Valerie.
Oh, okay.
Yeah, so this is going to be on you to do that. You know, one of the data elements obviously might be bowler's name. Okay. And however you want to call that. Then you got to break that down. So the bowler last name, bowler first name. Okay. And then we start putting our stuff into tables. Okay. And I conveniently given you 4 tables. Honestly, you could probably make 6 tables for this bowling league, but I'm only looking for 4. You should have at least have 4 tables. Okay. So, you know, you can always add additional things. Make sure that each table is normalized to the 3rd normal form. A table is in the 3rd normal form. If the table is in the 2nd normal form, every non-key column must depend only on the primary key. Okay. Then you'll need to start putting these tables that you've designed into your new database. So that means you need to create a database, and I've asked you to call it this. Okay. So that's what I would like you to call it. And then you just had to add these different things. You want to create your table relationships. And I tell you, use the database diagram. Okay. And, and again, I don't care what but you have to use your initials. Okay. And the reason you need to use your initials is that in theory, it would be writing over other people's stuff. Create a non-clustered index, because we know by creating primary keys, you create clustered indexes. Check constraint for a gender column. However you want to put that in. We're going to ask for that. Create a constraint for bullying score. In other words, your score should never be a negative number. I hope nobody can bowl a negative number, or it could be up to 300. And then you got to create the script like I showed you before. And that, my friends, is what you're going to send me. And again, I tell you, you don't have to do steps 1 through 4. I don't care about these. I'll be able to tell all this by your script. Does that make sense? So you don't have to send me all your work here. I'll know that by your script. Okay. But this is the data you're going to be dealing with. This is how the data looks. And again, I don't know if I'm concerned about you putting in this data, but it's a good way to check to see if your data works. Okay, if your database works. All right, go ahead, fire off your questions for me now.
So it's due by Tuesday midnight or Monday midnight?
Tuesday midnight.
Okay.
Yeah, so I'm giving you a little bit extra time. You might have questions. In theory, y'all can start now to do this, and I'm going to stay online for a little while, and if you have questions, you can consider this lab time. You can ask me questions. Yeah, please. This is actually what this class all come down to, is doing this. Okay. So this is really how we're going to test this, is by your script. That's why I made it worth 50 points, as much as a test. Okay. So any other questions? Well, like I said, I'm going to stay online. If you want to ask me something, feel free. If you want to start right now trying this, feel free to. But other than that, that's what I have for today. I'm surprised we made it through. But yeah, so hope this goes well for you. I'm sure it will. So if you want to get offline, you can, but if you want to stay online and talk, we can. All right. See you guys later.
See you next weekend.
All right.
Or next week, sorry.
Yeah, next weekend, whenever.